Have you ever stopped to think about what's running in the background of, well, everything? I'm not just talking about the big cosmic questions. I mean the fundamental science that makes your phone, your car, your entire world actually work. Today, we're pulling back the curtain on the hidden operating system of reality itself. We're talking about physics.
So let me just ask you that straight up. How does your world work? I mean, we're surrounded by all this incredible technology that we just use. We don't even think about it most of the time. For example, the internet, this global web that connects billions of people in the blink of an eye.
Or what about something like a life-saving MRI scan? You know, the tech that lets doctors literally see inside the human body without ever making a cut?
And of course, the absolute pinnacle, space travel, sending rockets clear of our atmosphere. Now, all these things can feel a little bit like magic, right? But they're not. They all run on the exact same set of fundamental rules. See, that's because behind all of these modern marvels, there's this invisible engine chugging away. It's a common set of instructions that tells everything in the universe how to behave. And that engine is physics. And the name itself is a huge clue. Physics comes from the ancient Greek word physis, which just means nature. And that's exactly what it is. It's the science that digs into matter, energy, and how they interact with each other. It is, for all intents and purposes, the instruction manual for the physical world.
Okay, but the scope of physics is, well, it's huge. It covers everything from the tiniest little particles you can't even see, all the way up to the scale of entire galaxies. So to really get our heads around it, it helps to think of it as a tale of two different kinds of physics, like two essential lenses we can use to look at the universe.
And this right here really shows you the great divide. On one side, you've got classical physics. This is the stuff that was mostly figured out before the 1900s. It describes the world we can see and touch, a baseball flying through the air, that kind of thing. But on the other side, you've got modern physics. This is 20th century stuff and beyond, and it deals with the world of the extremes, the unbelievably fast, the impossibly small, and the mind-bogglingly massive.
So let's start with that classical world. And don't let the name fool you. These aren't just some old, dusty ideas. These principles are the actual blueprints that built our entire modern society.
First up, we have mechanics. This is the science of motion, forces, and energy. If you've ever heard of Newton's laws, this is where they live. It is the absolute bedrock of all transportation engineering.
And its applications? They are literally everywhere. The car you drive, the planes flying way up in the sky, even the rockets that punch their way into space. Every single one of them is designed based on our understanding of classical mechanics.
Next, we have electromagnetism, the study of electricity and magnetism. Now, this branch led to maybe one of the most important inventions in human history, the transistor. And a transistor is really just a microscopic switch. But when you put millions or now billions of these tiny switches together on a microchip, well, you get the brains behind every piece of modern electronics.
I mean, think about it. Without our grasp of electromagnetism, you just wouldn't have computers, or the internet, or your cell phone, or even radio and TV. This one branch of physics literally powers our entire digital world. It's that fundamental.
All right, so now let's jump across that divide, into the other world, modern physics. This is where things get a little weird, a little counterintuitive. We're diving into realms that are totally invisible to us, but they've unlocked some of the most powerful technologies we have.
A huge part of this is nuclear physics. This is all about studying the atom's nucleus, that super dense core right at the heart of every atom. And once we started to understand what was going on in there, we unlocked some truly world-changing abilities.
For one thing, nuclear power plants, they generate massive amounts of energy by applying these principles. And in medicine, our understanding of the atom's core gave us these incredible tools like X-rays, MRIs, and CT scans, basically giving us non-invasive windows into the human body.
And then there's quantum mechanics. This is it. This is the fundamental rulebook for how matter and energy behave on the tiniest scales imaginable. It's the physics of the subatomic world, and honestly, its implications are just staggering.
Because here's the kicker. Quantum mechanics isn't just about weird tiny particles. It's the foundation that other sciences are built on. Take chemistry. You might wonder why atoms stick together to form molecules. Well, why do two hydrogens and an oxygen make water? At its core, that's not really a chemistry question. It's a quantum mechanics question. The rules of quantum mechanics are what determine how atoms can bond. Chemistry is basically just applied quantum physics.
So,
We've seen how physics gives us all this amazing tech and even underpins other sciences. But what's really interesting is that the act of studying physics, of learning to think this way, builds this incredibly powerful and versatile skill set that's valuable way beyond a science lab.
You see, when you study physics, you're trained to think analytically, to tackle really complex problems, and to build mathematical models to understand how systems work. And those aren't just academic skills. They are massively in demand in the real world.
And just look at the range of careers here. A physics degree could lead you to engineering, designing spacecraft, or into tech as a data scientist, or even to Wall Street as a quantitative analyst, building financial models. You could end up in medicine as a medical physicist. The applications are just endless.
Which really brings us all the way back to where we started. To see the world through the lens of physics isn't just some academic exercise. It's about understanding the operating system of reality itself, from the biggest galaxies all the way down to the tiny particles that make up you and me.
And that leaves us with one last, pretty exciting question to think about. We've seen how physics has built the world we live in today. So, what new reality is it going to build next?